Welcome to What is a View Component? Briefly, a little bit about me. My name is Mark Noonan. I'm a senior engineer at Cypress. We make a front-end testing tool to test anything that runs in the browser. I'm also a program developer at People Making Progress. This is a local organization near to Atlanta that does developmental disability support for adults with developmental disabilities. And I'm a volunteer at refcode.org. I would really encourage you to check out Refcode. It's another local organization, but you can also volunteer online. And they provide sort of initial training and skills and software development so people can decide, especially refugees and immigrants is the target audience. People can decide if they're interested in becoming software developers and how to get that training. These slides are online at this URL. I'll put this back up again at the end. This is mostly because there's links and stuff in it, and I don't want people to have to take pictures or try to write down URLs. They'll just be here in the slides if you want them. The general topic of this talk, so what is a View component? I've been using Vue for a long time, and when I started, I had the impression that Vue was like the easy framework to learn. And it was called that because it has a really supportive community, it has great docs, but I didn't find it particularly easy to learn. I could understand how to deal with copying examples and getting stuff to work, but there's sort of a mental model and a few things about just what are these components doing that are hard to develop instincts around. So this talk is kind of an exploration of where I am now, several years later, in relation to those things, and also a little bit about how we describe components ourselves, because the word component is so generic. And then finally, we'll talk about components in the sense of what designers make, so little things that mean something in terms of the user interface, versus the kind of architectural or utility components that we make that are necessary but are separate from those ideas. And one of the things I want to talk about is maybe when we should extract things that are there for kind of convenience reasons or are a pattern that we can use multiple places, but because they come with something that was designed, we decide we need to keep it with the original thing it was designed for. So the general sense that I had of what a View component is, and this is the definition across lots of frameworks, is a component is just like a reusable chunk of front-end stuff, which is both accurate but also tells us nothing about what a component is. Okay, it's any HTML or CSS or JavaScript that you can combine together or not and put on a page or not. So it's very generic. When we talk about a View component, there is a lot of specific lifecycle and structure stuff that comes with that. So we're bundling this little chunk of front-end stuff inside something else that has its own behaviors, it has its own features provided by Vue. These are the things that make it different from being a React component. These are the tools that we have available. So the format of this talk is mostly going to be a tour through some examples I've created. I want to highlight a few bits and pieces of different areas of what components can do. As I went through this, I found a few things that I had not already been aware of, so we're going to touch on those. Introduce the life cycle, introduce slots and props, how the Vue reactivity system influences what you can do when. We'll talk a lot about what a component's responsible for. I think sometimes even simple components can be responsible for more than it seems. And we're also going to talk about how to test what a component's responsible for. So when we think about testing, we really have to identify what matters and what does not matter about a component and focus on what we're testing there. And lastly, any one of these I could almost keep going for a long time. I don't want to go full depth on every single topic here, but we're going to touch on lots of different stuff. There's a few things we're not going to get into at all. This project is using Vue 3. These components are using the composition API and script setup. The Vue docs are really good at explaining what those things are. If you're new to Vue, I don't think it will impede your understanding of the ideas that we're talking about here. And if you're familiar with Vue, it would just kind of be repeating stuff that's not related to the talk directly. We're going to start really, really simple with a paragraph component. We'll work our way up to stuff that does interactions and has changing data and stuff that has API calls. But to begin with, we'll just look at this one simple paragraph component. And so this is a component test for it. It does what you'd expect. It says, hello, I'm a paragraph. And we have a spec that has an assertion here that says we expect the P of the paragraph tag to be visible. Make this a little bigger. And we can go over to the code for this component. Collapse some of this. And so in the code for the component, this is really the important part. I'm going to even move the rest of it off the screen for a second. So this is all that it's needed, right? This is a single file, one paragraph.view, single file component format. All that we have is a template and a paragraph. And so we think about, what is this component responsible for? Well, it owns this particular text. There's no other source for this text. This component's responsible for getting this text on the page and wrapping it in a paragraph tag, which means this component owns a little tiny piece of the accessibility tree that the browser is going to make. And that's sort of a hidden responsibility that we don't always think about when we start working with components. In a second, we'll take a look at how this is represented in the accessibility tree and why we want to consider that when we're writing and testing components. And so we're going to learn about the basic rendering of a component. I'm going to look at the single file component playground that Vue provides, so we can see just a little bit behind the curtain of like a Vue component is not magic. The single file component format is compiled into regular JavaScript that's doing some stuff that's Vue internals. And we're going to look at the initial component lifecycle events that fire when you have a simple component like this. So we have a few things in here. Let me restart this test. In the console, we'll start with the lifecycle stuff. We have a couple of logs, one from the setup, one from the before mount, and one from the mounted event. And these are lifecycle hooks. Bring them up here for a second. If you've read the Vue docs, you might be familiar with this diagram. I love it, but I find it as like introductory content. I'm not sure about it until I have examples and I'm logging stuff out. But we have the renderer encountering a component, which is like calling a function. We step into it, we run the setup, we do some other hooks like created. We know before it mounted, and then we have a mounted event. And once the component is mounted, we have this other set of lifecycle hooks that happen when data changes that the component is looking at. And so in our component here, we're logging some stuff. And you can see that we only got high from setup, we got high from before mount, and we got this mounted log. But we didn't get before unmount, before update, or on error captured. None of those things happened, so we didn't log anything. What these hooks give us a chance to do with our components is make a decision at a certain point in the life cycle about whether we want to change some data or do something that's a side effect of that. In a lot of day-to-day code, in application level code, you're probably not going to be hooking into these events very much. You're going to be using simpler patterns. But every now and then you need an escape hatch, and especially when you get out of a simple single-page application context, you start working with a Vue app that might be injected into a page that's got other things going on. It's possible that you might want to say, hey, after this has mounted to the DOM, that means the element is injected into the DOM, I need to cause a side effect to happen that will affect something completely outside of Vue that's looking for some present element in the DOM. I've worked a lot in some weird CMSs where the Vue app is just a part of a server-rendered page, and this kind of communication in and out of Vue when things are actually resolved and changing is a good escape hatch for those situations. And so you can see the order is hello from setup, we call before mount, and then we mounted, and the paragraph's in the DOM. The other part to focus on, let's take a look at actually, So we're not going to do this for every component, but we can do this as a starting point to see what does it do with just a template. So if this is our entire component, this is the preview of it, and we can see it got turned into some JavaScript. Because I'm using Vue, I don't care about any of these things. But you get a sense that what Vue is doing, it's got create element helpers, it's got a render function, we've got this sort of hard to read thing, and we're just going to get some JavaScript under the hood to produce the thing we expect to happen. So we'll move on and we'll look at a counter component. Counter is a real classic. So this is a very basic counter component. We can see that it's got a little test over here. I'm actually going to comment out the test so we can just see what it's looking like. So before we do anything at all, there's one important thing that I can't skip. It's this mount command that renders the component. It's pretty important to have that. We're going to remove the rest of this test. Cool. So this component is here, and we click the plus, and we get some behavior. We also get some new lifecycle events firing in here. So all these lifecycle events are, going to follow the same pattern of we're just listening for them in the script section in here, and we're logging when they happen. The important detail about the lifecycle event of before update is it's before we update the DOM. And so what we're looking at when we're in a before update hook, what we have the opportunity to do is deal with the data that just changed. So here we say, on before update, when this hook fires, the count has changed. The internal state of the component has already changed, and we're about to go do something with that. If that's going to take us to a state that we don't want to be in, or we have to have some side effect, again, this is less likely in regular application code, but we have the opportunity to inject ourselves into this life cycle to do something about it. And so this component is responsible for a few things. This component is responsible for this dynamic piece of text content now. It's no longer just static text like the paragraph. It does still have specific markup that it needs to render, and there's accessibility purposes to that markup that we're just about to talk about. It needs to spit out a button that increments the count, and the button should have an accessible name that's not just a plus. So this mathematical plus symbol is not very informative if you're listening to the page be announced by a screen reader or something like that. We'll take a quick look here. So here we have an ARIA label displaying on the button. And in our code, for the button itself, we're setting that. And we're doing that mainly because this is not an adequate description of the functionality of this button. Visually, I think you can understand it makes something increase, but it's not a useful label. And in typical situations, it wouldn't even be a character like that. It would just be an icon or something. So the way this is represented in the accessibility tree is available in our dev tools here. And this is something that is really useful to me when we're dealing with understanding what's going to be communicated to assistive technology. So I'll just stop for a second and explain that assistive technology like a screen reader is interacting with the accessibility tree the browser provides. This means it's not looking at the DOM directly. There's a separate tree that's made by the browser based on what's in the DOM. And that's what lets somebody listen to all the elements in the page and figure out what are the headings. They can skim lists. They can find out how long a list is. There's all this metadata about the nature and structure of the content that if we put it into the DOM, if we put it into our HTML, will be exposed for free to screen readers. So in this case, the button's label is going to be announced as increase count. And that's something that I care about this component doing. So that's a responsibility it has that we should consider writing a test for. So when we look at our test in here, we're thinking, what is this component responsible for? What kind of test do we want to write? First of all, when it starts out, we definitely want this to have this P here that starts out at 0, right? The component's going to be empty. So that's the first thing we care about. And then we have a way to select the button. This is using Cypress testing library. If you're familiar with like React testing library and that family of things, this is the Cypress kind of package for using these types of selectors. So I can say I want to find something called increase count with the selector of button. I don't care at all about the plus or whatever symbol's in the button right now. If I'm checking that, it might be checked from a visual test or something. But here, I want this test to fail if we break the label or remove the label. We might say, I don't know what that extra attribute is. I don't think we need it. At this point, the test should fail. But we're able to find this button. And then our test is going to click it a couple of times. And the final part of our test is going to be to assert that after we clicked it, the expected things happened. And so in this simple example, we're just going to say, all right, that paragraph that contained 0, we should not be able to find that anymore, but we should be able to find one that contains the number of clicks we did. And so our test is happy, it's passing, everything's fine. And if we did something like added an extra click on the end here, we start to fail because this actually contains 3. So the test is explaining exactly the relationship between these clicks and what we expect here. And that's kind of the contract of this component. That's the way to think about it's responsible for just a few things. It's still not nothing. It's still not something we can ignore. It seems like a very simple component, but it's got a few things going on. And it's got all these little extra hooks in here too. So let's move on, and we'll go to our third example. This is the counter with some styles. So I kind of wanted to complete this little sort of trio of the things that are part of a single file component. The HTML, right, the template section, the script section, and the CSS in the style block. And as we look at this component, we also have an extra thing being logged here. Let's rerun it. We have a watch effect. So the things that are happening inside this component are a lot more complicated, or can be a lot more complicated than just the lifecycle hooks. So watch effect is the example I just pulled out to give something that is part of Vue's reactivity system. We already saw ref, although we didn't talk about it, so let's talk about that for a second. The way that the button knows to increase this number here is because in Vue, we've declared it in a ref. And Vue's reactivity system is based on JavaScript proxies, so instead of saying the count is just the raw number 0, we call ref to wrap it in a proxy, which means Vue can be informed of when it changes. And so our initial function, same as in the last component, after the button's clicked, is we increase the count here. And because of some of this things that seems like magic, count++ is transformed into count.value, right? The internal state of this ref is going to increase based on that. And we have a watch effect here that is Vue's way of saying, okay, well, there's a ref that's changing, and I want to respond to changes in the data in this component. So in this case, because the watch effect mentions count.value, we don't have to like specifically watch count.value. We can just mention it inside this callback function, and we will start to react to changes in it, which means we can actually use watch effect to make a bug. We can say, hey, if the count.value, this internal state of this ref, if that's 3, we're going to set it to 5 instead. And so before it ever rendered the 3, we skipped. So this is in that life cycle, in the same space as sort of a before update, we've gotten into a place where we can modify something. Let's remove the bug. So we're going to move on to this paragraph with slots and props. And the reason that I wanted to make a paragraph that has slots and props is inside my counter component, I just have like a regular paragraph element here. And imagine this is slightly more complicated than a paragraph. I might want to have something I can wrap it in that will produce the expected DOM output. So what I want to do is I want to use a special paragraph component here that will have the ability to render out whatever content I put in there and maybe react to some props and some styles that I want to add through limited props. So not just having the class wrapping the paragraph tag, but having some intermediary with a prop. So this component is not that complicated. The template section will use a class that's based on props.size. And so we pass in the size that we want. This will apply that class. And down here in our style section, we have only one thing referenced, right? It's a large font size that makes the font 3 rems. And then we have a slot. This is where everything that is wrapped by this component is going to output into the DOM. So this is not something that we are defining in here. This is dynamic content. When we look at our test for this, we can see a few things. So we can see one test is large paragraph with expected content. The other is regular paragraph. I'll close this up for a second. And let's take a little look at this test, zoom in a little bit. Focus on the first one. So we can see this is bigger. And we have a couple of ways that we can think about asserting this. We know the component's responsible for reacting to a prop. How did we define the responsibilities here? Dynamic styles based on a prop, dynamic content in a paragraph tag. The ways of checking that it got the dynamic styles from a JavaScript-based test are all sort of unsatisfactory to me. This is the kind of thing I would like to take a visual snapshot and do a visual regression test for. We're not going to do that in this talk, but we'll show some examples of when you don't have that, there are a few things you could check. One thing is we can check, hey, sci.dot contains p.large. That would be a sign that this size prop was applied. So it's easy to check that the class is there, but it's not very meaningful because even if the class is there, the class needs to have certain CSS with it to be having the effect. And even if the class name changed, as long as the actual component looked the same, we really shouldn't fail the test. It's providing the same function. So there is like another option, which is to look at the computed style of that paragraph tag. And we know the default text size is going to be 16 pixels. And remember, we defined this in rems in the component, so we didn't say that this is going to be like a 48 pixel font or whatever. But we can have an assertion in here that says, okay, get the paragraph that has this custom content. And we're going to do some shenanigans here to grab the actual font size in pixels and just say it should be bigger than 16. This is still a hoop I wouldn't bother jumping through. I would have a visual regression test. But the purpose, the spirit of this is we want to know the dynamic values we provided. Did they work? Did they do something? And likewise, if we didn't provide dynamic values, if I take away the only from this test and I say we get a regular paragraph, the difference here is we're not providing a prop at all, so we have different expectations for the font size, and we can even say we can provide different text that we expect. And the reason that we do this is that it's possible a component could be modified to ignore its slot and just put the one set of things the test is expecting. So we want to mount a couple of times with different content. Let's see what we did here. We're getting a failure. And the failure is because I've got 2 exclamation points in here somewhere. There we go. So it can't find something with that text. And so here we're expecting that the font will actually be 16 pixels. We haven't passed any prop in here. So we've tested like this surface contract of the component. Developers are going to use slots and props. Users are not going to use slots and props. But in terms of the responsibility of this component, it's got developer-facing and user-facing aspects. And we should test those, but I'll highlight that we should only test those here when we're speaking about this particular component test. When we look at higher level components that might use this, we're only interested in what it actually does in the DOM. But when we're testing this component, I want to know that that size prop is always going to do the same thing and have the same name, especially if someone's consuming this in another team. It's really valuable for the component test to test that. So now we've made that component for the purpose of using it in the counter. And we'll switch over to this counter component. So this isn't doing anything different. If we look at counter using paragraph, it is doing some different things internally. It's got paragraph with slot and prop, where previously we just had a p tag. We're passing this count ref into the slot of this, wrapping it like an HTML element, and we're passing size large. And so we do see some different behavior here. This number is bigger now. We have this reusable paragraph component. And we have got a little test that's the same because we haven't changed. Looks like maybe we added the large, right? We've changed the assertion on the test here. But the internal functionality, in fact, let's change that. Oh no, we're not asserting on it. Cypress is reporting it because it happens to have this tag, this class, but all we care about is the same as it's before. So in this component test for the counter using the paragraph, it doesn't matter at all that we refactored the internals. And as we're thinking about components and developing them, this sense of only that component is responsible for knowing the size prop even exists. The last thing I want to do in this test is say that counter using paragraph should have some specific child, and that child should have some value in some prop. This is not responsible for that, so this component is not going to even think about it. We're just going to look at the output. There's another aspect to this that was a little surprising to me as I was learning Vue, so we'll stop on this for a second, and I'm going to reload this test. Yeah, let's just let it run, and we'll see. So we have 2 different sets of logs here because this is the first time we have one parent component that's calling a child and rendering it. And the thing that's worth noting in here is we have this setup function. So setup is called on the counter using the paragraph, on this outside component. And the before mount event fires saying, hey, I'm about to put this in the DOM, and I'm going through the component. Then we encounter this. We're going through, and we hit this paragraph with a slot and prop. And this is when the single file component, like when the lifecycle hook says, yeah, there's something about this. Renderer encounters component. So that's what's happened here. The renderer has encountered this child component, and just like a function call in JavaScript, we're going to step inside and we're going to deal with that before we go back up to the parent. And so we have these hooks that are firing inside this child paragraph with slot and prop component, and their order is the same, but they're injected before we go back up and decide to mount the parent component. I don't know especially since working with Vue 3, where the reactivity seems to be so much simpler, I don't spend too much time having problems related to this. But I think my mental model of how components render was just probably a bit wrong until I sort of stepped through like this and thought about some of those details. So now we want the counter to start emitting some events. And part of the idea here is we do simple things that add up pretty quickly to have more complicated effects. And it's really easy to just do stuff and make the next thing you need to work and just keep doing stuff and not necessarily see that things are getting complicated. So this had a lot of stuff going on. Let's take a look at what this is responsible for before we get into all of its behavior. So it's going to be the same as the counter using the paragraph. It's that same component, just a new version of it. But it's responsible for submitting an event. And we're going to say, hey, when the counter hits 5, I want you to fire an event that a parent component can know about. And I would consider this the simplified example of like form input state, where maybe we have an error type of input. You know, hit a state where you've written something that's too long and we need to tell you that you can't do that. Or you've used, something that's erroring in a form field. So that's one state of this. We want to say, hey, when we get to 5, I want you to emit this event called like count it to 5. But then we also want this component to throw an error when you go to 11. It's not allowed to go to 11. And so this is something we'll be able to watch and put into the component to say, hey, if this happens, throw an error. If we reach this weird condition, it's actually bad for the user to continue to be able to use this. So we need to destroy this component, throw an error, make a big deal about it. So what we're going to learn about is testing an event, looking at the event side of a component contract. Sort of like we said before about props and slots, this test is going to be the only place where this event name has any meaning at all to us in our application. And then we'll also have a test part of this that explains the component throwing. So here's the component, first of all. We'll look at its behavior. This section is the same. We've changed our simple plus plus by this point to be a named function that we can look at. And because of that, we have count.value in here. The old magic of count plus plus only applies in the template section. Here we're in this callback and we're much more aware that we're setting a property in an object. We're not setting a raw value. And I kind of like that. I think there's ways to make that go away, but I like the reminder that this is how the system works. So there's two things here. We're going to emit an event that we've defined up here, and it's just a string to say this is the name of the event that we're going to emit. It doesn't have like a payload or any content. We're just going to say we count it to 5. We're going to do that by looking at count.value. Since we update that when we click, if we just updated it and now it's 5, we'll emit the event. If we just updated it and now it's 11, we will throw an error. And this was a relatively new discovery for me in how Vue handles errors. So there's nothing we can do about the error in this component, but when we get to the parent, we'll see how we can capture that and confine it to the place that it happened. And let's take a look at the test. So we're starting out in this sort of same familiar way. There's this extra step we're going to do though, because we need to click a bunch. So we have the usual, it should start out at 0. This time we're assigning the button into an alias so that we can repeatedly get it. And this is just some stuff to click it 10 times. And so let's bring the test to there and pause it. Cool, so we've got 10 clicks. And we have a passing assertion here that says expected counted to 5 spy to have been called exactly once. And we can see that it's mentioned here. This was the alias that was called. And we can see it was called in the middle of our clicks. So this test is probably not complete, right? You might want to stop at 5 and make sure it's called, and then do another test that clicks more times. But what we're seeing here is that there's something that's catching this event. So let's talk about that in the test. This is my preferred way to test events. So there's really two approaches you can use. Cypress Vue testing is built on Vue test utils. So you have ways you can access like the Vue test utils wrapper and the VM through there. And you can get the emitted array that you can get, like the Vue test utils makes the ergonomics easier to get the emitted array. But then you could go, okay, this component instance should have emitted and assert about like exactly what the array contained in terms of emitted events. But I'm not really interested in testing that because that's a very Vue-specific thing. And if you notice, as much as possible, we're holding these tests as far away from Vue as we can. So this mount command is getting a like JSX version of the component. We're passing in a handler here. That's just this spy we created. And the reason we created that is that when this fires and calls this function, we have something to assert. And if this was like not a prop, if this was not an event, if this was like a callback prop or something in React, the test would look really similar. So as little as possible, we're dealing with the framework. We're caring about what is the component supposed to do for the users and what's it supposed to do for the other developers who are going to use it. So now we've reached this point in our test and we've paused. I'm going to play the rest of the test. We got some other behavior here. We see something about an error. The test is passing, so there must be something that's testing that error. And we also have some stuff in the console. So if we look here, we see this error, uncaught error, this one goes up to 11. And the reason that our test is passing is because that's the expected condition of this component. We have done something illegal. We have broken the rule. We've gone to 11. And so we want to test that that happens. And the code for that, and I don't want to get into the weeds on all these kind of testing examples. It's more about like the kinds of things you can and should think about testing. I didn't think about testing that a component should throw an error until pretty recently. But we have a way to grab an uncaught exception that's coming from our component code and assert, hey, this message includes the error. This one goes up to 11. So just like the spy above, I have something I can call when that happens. And this is the only time we call it. Otherwise, we're still going to fail. And if the component throws, the test will fail and say, oh, this wasn't supposed to throw this kind of error. Only this one valid thing should let us avoid Cypress failing the test. And then we have our little get to come and get our stub from here and say that it's been called. So this component safely throws an error here in the test, and we're going to use it in a parent. And the issue in the parent is going to be, how do we capture that error and respond to it in the appropriate way? So these component names are getting increasingly silly because they're doing increasingly silly things. This is called fetch after counting to 5. This is going to listen to those events that we just made, and it's going to do something. In this case, we'll make an API request. There's a Star Wars API. I love it. We can just hit that. We'll get something back. It has a couple of other things it needs to do. It needs to show us a loading message after we've kicked off the request. We need to show a character name that came back from the request. And then we have to handle this annoying error from a child component after you count to 11. So I think the way we should approach this is to, let's make it really simple first. I'm going to make a new block at the start. We're going to say it.only. And we're just going to mount it. So I will do this sometimes as I'm developing something if I haven't really figured out exactly what tests I want to do. Let's refresh here. And I'm still in the old spec. Here we go. So now this component's got some behavior we just talked about. Let's see if it's really doing it before we look at the code. We'll open up the network tab. Let's clear everything out here. So counting behavior is working as we would expect. We get to 5. This network call appeared here. We got some data in there. Did we get a loading state? We probably did. I didn't see it. And then we continue. And then we got to 11, and there was no error. There's no error in the console. We're giving Nigel Tufnell credit for things going up to 11. That's what we've done in response to the error. There's some more stuff logged in here. We can see things happening from the child component. We can see things happening in the various parents. And we can see this error was captured. This will return false so the application doesn't throw. This means we said, okay, you're not allowed to use the counter anymore, Mr. Tufnell. You have to stop. And for some reason, that's the behavior that we want from this component. So what we're going to talk about is how we're handling that emitted event in a Vue component, and a little bit about how we would test this component that touches an API. This calls an external API. Do we want to hit it every time in a component test? Maybe not. Do we want to stub it to produce a certain result? And we'll look at the on-error captured event. So here's our component. This is a new parent component that we haven't used before. This has our counter emits event stuff, and it's also got this div that it will do if there is a person from the Star Wars API. Oh, I wonder if I should fix it. Probably should fix it. Because all that stuff is like, yeah, it's a ref on state now. Cool. So this is that counted to 5 event that in our test in JSX land was, go back to number 6. This was written as on counted to 5 in Vue syntax. It's at, and we're using this like snake case. And so what we've got going on in here is an empty ref for the Star Wars person. We've got a state that's a ref of like just what's going on right now. Are we going to show loading or not? And we've got this event handler. So very similar to the one that we wrote in our test that was just like, hey, this was called. In this case, we're going to react to this event. Counted to 5 is going to call this handler function. First thing it's going to do is set the value to loading. Then we'll fetch just people1. We're going to always get, that's funny, we're going to always get this one character from the API, and we're going to always set it to the value of Star Wars person. And then through Vue's reactivity system, when the value of this ref updates, we will have a person in here that we can show. So that is the process by which we're handling this event. We go up to 5, we can see that it happens. And so when we're testing this, we have a couple of options. This component has behavior that goes in a couple of different directions. So one test option that we have is to do some activity that's supposed to cause an API call, and then watch the DOM and see if the appropriate response happened as a result of the API call. There's an intercept here that we'll talk about in a second, but I'm going to take that away and just run this test. So this test is passing. We can see that we did all of our clicks. We have a loading state in here. And as we go back, Luke Skywalker showed up in there. We're expecting this list item with Luke Skywalker. So we're saying this should have a specific DOM element because, again, that will be exposed in the accessibility tree. And then we click it one more time, and we expect that we'll have the same type of item, but this time it'll say Nigel Tufnell. And we might also want to say, okay, well, the button shouldn't be there, the count number shouldn't be there, those other parts of the behavior. I think even when I tried to summarize the responsibilities of this component, I didn't do enough to explain all the nuances of what it's doing. So we have that option, which is to look for the side effect in the DOM. There's not always a side effect from the DOM. So the other thing we can do is we can say, okay, well, I actually don't care about this middle step. I don't care that it says Luke Skywalker. I want to wait for it to say Nigel Tufnell. And so I can wait for this request itself. And the reason to do that is that there's a delay. So if I run this test now, oh, look at that. I guess it does. It shows up eventually anyway. There are situations where there will be a delay, where you would have a test that does a bunch of behavior and expects something to happen, and you're asserting too quickly before the API has resolved. And I think that's what the order is. Let's bring this Luke Skywalker assertion down. We're not waiting for this anymore. We got that behavior. And so this, yeah, there's a little bit of stuff where we want to be sure that we've waited for the API call. Even in this order, though, I don't want to get too in the weeds of how exactly to make this fail. I should have worked harder to figure out a bad test for this. The point is, we have this responsibility. We're able to test for exactly what we want. And we have this whole other option. So this is just the render one. And here's a test that's going to intercept and not just like pay attention so we can wait for it. It's going to add some data to respond. And so if we look at our test now, we have a failing test for this intercept version. And I wonder why we're failing. Oh, because I've left out the name. So the old test would have been Luke Skywalker. And this will fail correctly because our intercept has provided different data. So in this case, we kind of incorrectly, to get this test pass, would need to say, hey, when I request people 1, I actually should get Chewbacca. And now we've written a passing test, hopefully. I removed the name while I typed it. Cool, so now finally we're happy. And so we got this little Chewbacca. And so at this point, we have a test that's passing because it's doing like simulated data. And I don't feel so great about this, right? We expect a certain value back from this particular API. So we should simulate different values, but we're not calling more than one. And so the reason that we would use a fake name in here is that it's important the component is actually hitting the API, because we could also make it pass by doing something else to put Luke Skywalker in there every time. So this dynamic value in the test is the only way to be sure that it will render what comes back when it hits this. And so we could put any sort of test data in there, make it as big as we need to make to simulate the object that it should work with, and then we can assert that we got that behavior and we still got the old Tufnell stuff. So that is the last of these kind of big examples. I want to talk a little bit more in general now as we wrap up. We've just sort of been doing stuff to get to know Vue and explore some of these features and make the next thing that we need. As we make bigger and bigger apps that need to live for longer, we probably need better names than the ones that I made up on the fly for these components. And one of the bigger questions that people who are new to Vue are asking is, when do I have to break this up into components that are smaller? And what's the rule? How many lines, how many features, how many things have to be happening in there for me to break this up? We just sort of saw that there were no rules, right? We wanted something for convenience to have a paragraph that has certain behaviors, so we did that. But one clue that things should be broken up is when many things are overlapping in the component's responsibilities. They don't strictly go together. So fetching data and updating the DOM with this response in a small component situation might make sense, but if every component is reaching out to fetch data, especially if we're starting to fetch the same data from multiple components, it's a suggestion that that stuff might not really belong in our components at all and can be put in some extra place where they can access them. So I use a few loose categories to figure out what goes together. This is where I kind of wished I could give you a magic system that would explain, here's exactly what everything is all the time, and it doesn't exist. But I think about the base components. I think about something that's going to be used in many variations that needs to provide a little bit of a building block, but is not in and of itself any single complicated thing. Our paragraph is probably like that. Our utility or helper components, these would be things that we might make for the API call. So we've got a few ways to make that API call more testable and easier to think about by removing it from the component and maybe having a wrapper that gets the data and provides it as props. And so that wrapper can handle fetching data, and you can maybe pass it something so it can know what it has to fetch. And then our component that renders the Star Wars character in the counter doesn't have to know there's an API. That's a good way to isolate it and make it more reusable across different situations. That would be a sort of, I guess, coordinator component, especially if you wanted to fetch data and set it in a store and do some other side effects. I look for components that are doing things that are kind of like moving the pieces around, and I try to find that functionality and separate it from rendering content and making stuff from the design. We have page and view components. This is nice because in your standard Vue CLI project, you get a views folder, and you can often have like route guards around a page to make sure that we've checked, is the user authenticated or is something else happening that has to happen before we render the entire page. And then we have layout components. These are also not putting out a whole lot of DOM elements. They might be putting out some divs and spans to arrange things, but these are generic ideas around, okay, is this going to be a row of 5 things and it stacks when the window gets small? Like that's behavior that we're repeating. Sometimes a layout component doesn't need to exist and can just be a couple of CSS classes that you reuse over and over. Likewise, there's style helper components. If you're in a Tailwind-driven, utility-driven environment where you use that for everything, the recommended pattern is to create a Vue component that contains your list of utility classes to encapsulate some reusable CSS. And the last thing is design entities. These are a little bit different. These are special. Design entities would be something that's actually in the context of a component. I want to quickly look at the Vuetify example here, where we have buttons and breadcrumbs. These are examples of design entities. And then we have things that are more helpers, like the grid helper, the lazy loader component. I realize we're running out of time, so I'm going to kind of skip the last couple slides here. This is where we're going. There's no magic system. We've got this example in Vuetify of really good Vue components that are design system elements, and we've got components that are not. And then we have behavior that's like separated, has to be separated from something that you see in a design file. So if you go to Figma and you see a certain type of card, that's a useful thing, but it also has some behavior that's like, okay, well, when you hover, it has this particular shadow effect or something. That's probably not connected to the core identity of the design component. And those are the things to watch for that you can extract and separate the utility stuff from the design stuff. So I think we should sort of call it there. I'm around. There's a bunch of resources in the slides. The link is back at the top. And the tool we use for Cypress component testing, which is maybe, I'm looking like I have a watch, but maybe out of beta already, definitely today, tomorrow, look for that feature to be like a full part of Cypress. There are Vutensils is a really good example of a component that separates, or component library separating style from behavior. I know Austin is like here at the conference who wrote Vutensils. And there's a bunch of little bonus things about screen readers and how accessibility affects users using the web. which is like critical to your component testing and your component development. These are some things you can do that we don't have time to talk about, but I'm around for questions. I'll like come down and we can just chat, and I'm around for the rest of the day at the conference. So yeah, thank you very much.